Hello everyone, welcome back. We are looking at integration of trig functions. This section right here we're talking about is the indefinite integral. And so we're going to go ahead and get started with these problems. Remember that when we are looking at question number 1, we're integrating two separate things being subtracted from one another. We can actually integrate them separately. Now one thing you want to be careful about is your signs, S-I-G-N, of your trig function. So remember when we're taking derivatives of trig functions, we would change the sign if we were trying to take a derivative of a trig function that began with a c. Well, now what we're going to do is if the answer is either cosine, cosecant, or cotangent, then we would actually have that sign change. So the more examples I'll do, the more that will make sense to you. So if we're looking at example number 1, it says 3 secant tangent. So you have to ask yourself which trig derivative is secant tangent. Remember, we're going backwards now. So hopefully you guys remember that the derivative of secant is secant tangent. So if I integrate this, this is just going to be 3, and this is going to be secant of x. Remember that we could actually pull out the constant if we wanted to, and I'll do that over here in example number 2. So 3 secant of x, the derivative of secant x is secant tangent. So we're going to go ahead and keep the negative for a second and do the 2. Remember, what's cosecant? So cosecant, cotangent, well, that's going to be cosecant. That's going to be cosecant. But remember, ladies and gentlemen, that whenever you're taking a derivative and whenever you're integrating and your answer is a c, you want to change the sign. You want to change the sign. So that's a little bit different. But again, if you guys can think about it, what's the derivative of 2 cosecant? It would be negative 2 cosecant cotangent. So it's just one way to kind of think about what we need to do for these problems. All right. So it's just really being comfortable with what the actual derivative of these things are. So I know the derivative of 2 cosecant would be what you see right here. So I know the answer is correct. If we look at question number 2, we can go ahead and pull out the 5. And I'm all about rewriting stuff, right? So we know that secant is the same thing, 1 over secant, I should say, is the same thing as cosine. And this is a really good example of this, is that we're going to integrate cosine. We're going to integrate cosine. Remember, ladies and gentlemen, when we integrate cosine, we're going to get positive sign. Because again, this does not begin with a c. So we're going to keep the sign of this the same, or positive in this case. So this is going to be 5 sine of theta plus c. All right, so just be careful with that. I've written this up several times before, and I think this is actually really helpful. So let me get to another page for 1 second. I think this is actually really, really helpful. If you write down SC, SCS, and then the third and the fourth one are negatives. So when you're going down, you're taking a derivative, right? D for down, D for derivative. When you're increasing, I for increasing, I for integration, you do this. So if I'm integrating cosine, I'm going to get positive sign back. If I'm taking the derivative of cosine, I take negative sign. So a good one to look at here is, let's say if we're taking the derivative of negative sign, it's negative cosine. But if we're integrating negative sign, it's actually going to be cosine. Because again, if we're integrating, if the answer starts with the c, we have to change its sign. And that's kind of how I always think about it. Okay, so let's look at example number 3 now and continue on. The integration of 1 is just going to be x. Remember, we can separate these because they're just subtracting from one another. And then this right here is your arc tangent, right? It's going to be your arc tangent. Now we're going to start talking about how to actually integrate that, where this is not the exponent plus 1, but this is what I call the skeleton, right? So this is going to be our arc tangent. And so then we're done with this question. All right, we're done with this question. And you can also write it, if you guys wanted to, like this. Either of those is fine. For question number 4, you can do a couple of things. You can actually split it. Okay, you can split it, and you can do, this is not the smartest thing, and I know you guys already know what I'm going to say the easy thing to do, but you could split this, right? And then do that. This is just going to be, 1 over cosine, and this is going to be tangent squared, but that is really, really, really crazy. We do not want to do that. That's a bad idea. So what do we want to do is we want to use identity, right? So we remember that sine squared x plus cosine squared x is equal to 1. So if I were to do 1 minus sine squared, then my top is going to actually just simply be cosine squared x. So knowing how to rearrange that, we get that answer. So this top part becomes cosine squared. The bottom is cosine squared. So we simplify it down to 1 dx. Now, guys, do not forget we're still integrating here, right? If my answer is not 1, we still have to integrate 1, and so we're going to get x plus c. Okay, so that's a really complicated way for us to say 1, but that's really all we have to do for that. Okay, so let's look at example number 5, and after a couple more of these, like if we really don't need to do too many of them, right? So question number 5, we pull out the 3 again, and you don't have to, but it's just easier. And just like before, this should look very familiar to you. This is going to be the derivative of arc sine. So we're going to go ahead and write arc sine. Okay. So that's the idea from these questions that you're going to see right here. I'm just going to really quickly do question number 7 and number 9, and I think we're going to be good with these type of problems. But question number 7, and again, this talks about the sines. This is talking about the sines. So the derivative of the function whose derivative of secant squared is tangent. So when we integrate secant squared, we're going to get tangent. And then the derivative of that's the function whose derivative is cosecant squared is cotangent, right? It's cotangent. However, once you write the c, so once we write the c, we're going to change the sign. We're going to write the sign like this. Because guys, remember that when you take a derivative of a function that begins with a c, you do change its sign back. So if your antiderivative is a c, then you're going to change the sign here. So that kind of helps with that. And then finally, ladies and gentlemen, question number 9 here. I could pull out the -5, so it'd be -5 integration of 1 over 1 minus x squared, but we've already said that that's an arc sine, right? So that's the arc sine function. And then we're going to have minus pi, because remember, pi is just a number, just like right here with minus pi. And then we've already talked about the secant squared is just going to be tangent of x plus c. And then I know I just said we were going to do it, but this question number 10, this is another one that's just really easy to do. The cosine squared plus sine squared is just 1, right? So use the identity. Absolutely do that. We are going to learn later in this course, very soon, actually, next couple lessons, how to integrate cosine squared x by itself. We don't need to do that right now, but we could separate these and integrate them, but that would just be a hot mess. This is just going to be 1, so this answer will be x plus c. X plus c. And actually, really quickly, I just noticed over here, question number 9, that we could, if you wanted to look at this, we could actually have the 5 pulled out and see -1, right? -1 over this, and that would have given us positive. So we could have also said that if we had a -1 here, well, the integration of -1 over the square root of 1 plus x squared is the arc cosine. So that's actually another question that I wanted to talk about for a second, is that, remember, the derivative of arc sine is 1 over the square root of 1 minus x squared. The derivative of cosine, arc cosine of x is -1 over the square root of 1 minus x squared. So I could essentially say that that's a -1 right there, pull the 5 out, and then I have the cosine, the arc cosine. Or I could leave the 5 alone and just pull out the -5 and just have the 1. So both these answers are correct, and neither answer is better than the one before that. Okay? So we're going to finish this video up with another random question where we do have to integrate with a little bit more thought. But this question right here is saying, suppose that the curve y equals f of x has the property that at each point x, y on the curve, y satisfies the conditions that the second derivative is negative sine x, and that the line y equals 2 is tangent to the curve at the point where x equals 0. What is the equation of the curve? So we can look really quickly and notice that at x equals 0, so that's on the y-axis right here, that at some value, when y is equal to 2, we have some curve that y is going to be equal to 0. That's going to be our tangent line of our function at x equals 0. So we want to find the equation of the curve. So the first thing we got to do is we got to go from the second derivative to our first derivative. So the first derivative is going to be equal to the integration of negative sine x dx. And this, ladies and gentlemen, we can go back and look at what we did here, right? We're integrating negative sine. Whoops. We're integrating negative sine. So when we integrate negative sine, we actually go to positive cosine. So down here, we're going to write that this is going to be positive cosine plus c. And again, that is going to be our derivative. So our first derivative is going to be cosine of x plus c. But remember, when x is equal to 0, we have a tangent line. We have a tangent line of y equals 2. So my derivative value at x equals 0 is going to be the slope of the tangent line. Well, the slope of y equals 2 is 0. So I can say that 0 is going to be equal to when cosine of x is 0, right? When x is equal to 0. And that's going to give me what my c is. So my c is going to be equal to -1, right? So 0 plus 1 plus c is going to be -1. So then I can conclude this piece of the puzzle by saying that my first derivative is going to be cosine of x minus 1. And now to get to the actual function itself, what is f of x? We're going to integrate our derivative, right? We're going to integrate our derivative. And so when we integrate cosine, again, we could go back and look at the chart that we just had right here if we wanted to. But it's just going to be sine of x and then minus x plus c, right? And this is our second c. So when we do this one, well, if this is x equals 0 and we have the line y equals 2, then the point on the curve 2, 0 has to exist, right? How else would this line, this has to be tangent to the curve. So if it's y equals 2, it has to go up to y equals 2. So the point 0, 2 actually is a solution to our problem. So let me erase this little piece right here, because we already know what that is now. And let's continue on with the problem. And so that when y is equal to 2, we have this, right? And so this is just going to be 0. So c is going to be equal to 0. So our final answer for this problem is going to be f of x is going to be equal to sine of x minus x plus 2. And now this satisfies everything that we have in our problem right here. All right. So we're going to come back into our last video and start talking about more integration of trig functions. So I will see you guys in that video.